All right, in this video, we're actually going to start looking at transformations of different graphs. Starting off, I want to make it known that we're going to move from f of x to g of x for each of these functions, where f of x is going to be my red function and g of x is going to be my blue. So starting off, the first function we see is a quadratic because it looks like a U. Now, knowing this isn't 100% important or necessary, I mean, it just doesn't hurt. Now, the steps to do this, if you want to write these down, okay, the first thing I like to do is find vertex of both graphs. All right. The vertex is a key feature that we looked at in Math 2. For a quadratic, it's either the highest point or the lowest point. After I do this, what I'm going to do is find my directional shifts. What I mean by finding directional shifts is I need to go from the vertex of my pre-image, which in this case is the red, to the image, or in this case is the blue. And again, just the vertex or the dot we made. So I need to go to the right. And then I need to go down. So horizontal shift right. Vertical shift down. Now, just being able to know how to do this is going to allow you to get or eliminate one or two answer choices based off of the directional movement. And then we can actually go find how much. So we go 1, 2, 3, 4 right, and 1, 2, 3 down. Again, that's going to let you possibly eliminate another answer choice. The next thing I like to do after I find my directional shifts is reflections. Now, what I mean by reflections, does the way the graph look changes? So in this case, the red graph is a U, and it changes to a U. So if the shape is the same, then no reflection. The last thing I do is stretches and compressions. So I have to imagine or pick out points to help me do this. I like to just, look at it. So the last thing I do is stretch. Or compress. And again, red is my skinny graph. Blue is my wide graph. So this is compressed. If it was wide to skinny, it's a stretch. Very, very, very rarely will you have an NA when given just your graphs. Okay, NA means that it wasn't a stretch, it wasn't a compression. I'm going to skip that one, and I'm going to come over here, and I'm going to do number 4. Again, the name of function 4 or question 4 is a rational function. Again, I'm still going from red to blue. Now, if I look here, there's a couple of points that interest me, all right? This point and this point for the red, and this point and somewhere close to here for the blue. Now, as far as choosing one, the way I like to do these is, so my red graph, if I want to think about it by itself, it looks like this. And it becomes the blue graph, which also looks like that. So if I just look at only one of the pieces, so I'm just going to look at that piece and that piece, and I'm going to compare them. Okay. I'm not going to, however, worry about this part of the graph anymore. Right? It's just more to look at. So again, first thing I do is I want to go from that point to that point, or from these 2 points. And again, I'm starting with red, so I'm going to go left. Then I'm going to go down. So I went left and I went down. Now by how much? It looks like I go down about 1 and left 1, 2, 3, 4, 5, 6, 7. So about 7 left and about 1 down. To get these exact with rational functions is really tough unless you're actually given the equation. So you can just approximate here. And in doing this up here, for reflections, I can look and see that my shapes haven't changed. Therefore, there has not been a reflection. Now, as far again as vertical stretches and compressions, to me, it looks like, so again, am I going skinny to wide or wide to skinny? So you just have to make this call. The blue graph looks wide. The red graph looks skinny. And again, we're starting with red, going to blue. So I want this one. And this one also happens to be a compression. And also, again, guys, the reason I say save this one for last is it's the toughest, especially the further your graphs get away from each other. But by the time you do your stretch or your horizontal vertical shifts and your reflections, you can probably almost beat a 1 or 2 answers that's going to have eliminated answers that aren't going to have the same answer piece for your vertical stretch compression part.